Okay. Is this better? Ah, okay. Okay. I'm Giacomo Bergamo. I'm with Invincia Labs. Um, I wanted to demo for maybe 10, 15 minutes our Cynomix malware triage tool and invite you guys at the end to also register to use it if it's of interest. And then I'll also answer any questions. So Cynomix is the result of about, it's the offshoot of about 4 years of DARPA research. Uh, Myself, Josh Sachs, Alex Long, Siegfried Gold, and Robert Gov were involved in this project. And the purpose of the Cyber Genome Project was to come up with technologies that would help analysts deal with malware at scale, because you're being hit with hundreds, thousands, millions of malware samples, and you need some way of reducing the workload. Right now, the standard way of dealing with this stuff is reverse engineering one file at a time, and that's not really scalable. So we developed several technologies to do some first pass automatic analysis of the files and also cluster similar samples together to help out the analysts. And we built several visualizations and workflows that could be used to reduce your workload. So here's the landing page for Cynomix. What you see is what we call our Cyscape or cyber landscape. And all it is imagine a 2D plane divided into 256 by 256 bins. And the spikes represent the count of malware samples in each bin. And when our system processes malware samples, what will happen is that malware samples that are very similar will end up in the same bin or nearby bins. This way, even if you're looking at a data set of thousands, hundreds of thousands, millions of malware samples, you will still be able to observe trends. So let's say you have a spike emerging somewhere. Maybe you should go and look at what is happening there. What are those malware samples? Or if you filter the data, you could look at the landscape for two different intrusion sets, let's say, and at a very high level determine whether they're similar or different. So in addition to just being some pretty 3D thing, it actually has some use. So like I could actually click on one of these bins and get some summary information about the malware that falls in that bin. For example, the top capabilities. And then I could navigate to some other section of our tool to look at those samples more in depth. So let me just click on this, and it takes you to our faceted search view. And just to give you an example of how these bins work, what we see here, I'll come back to this a little later in more detail, but what we see here is that most of these samples have this compresses or decompresses files and uses gzip capability that we automatically detected. And that's one of the primary things that made these malware samples fall into that same bin. In addition to the capabilities, the file type and the rare strings that we extracted from the malware samples all go into the calculation of what bin it should fall into. So, this is just a fun thing to play with. But other entry points into the app on this landing page are this search box where if you already have a file that you're interested in, you can enter the hash and go to what we call our home page for that file, which gives you all the analysis that we performed on it. If you're logged in, you can upload new files and label the group with some label. Or if you've been uploading files, you can view reports on the analysis that was performed. So I uploaded a couple of groups. This is the report for one of them. For each file, it gives me the capabilities that were detected, and then it gives me shortcut links to other parts of the system, like the home page for that file. If there were any similar samples, it'll take me to the comparison view for that sample, and then the exploratory views like the faceted search and the Cynet, which I'll get into. So this is just a way of keeping track of what you've uploaded and looking back at reports about them. So let me go ahead and go into the faceted search mode of using our site. So this is like faceted search like you might see on Amazon.com, but instead of searching for televisions, 1080p, Sony, you're going to be filtering down the data based on things pertinent to malware. So maybe you'll want to filter down by the group labels that you gave when you uploaded stuff. Maybe you want to perform full text search, and this will search everything from file name to names of resources and DLLs inside the binary to any string features that we extracted when we broke apart the binary into string tokens. And then filters. So we have our automatically detected capabilities. We have things like strings, IP addresses, host names, so, and then tags that you or other people may be added to files. So you can use any combination of these to filter down to malware samples that are of interest to you. So if I filter down to a particular group that I uploaded, so I uploaded some samples from Putter Panda, which was a Chinese set of malware. You can start to see the power that we have even in this simple search view. So every row here represents a malware sample, and then you have the name of the malware sample. If there were any images extracted, you'd have a little icon, and then you have what we call our capability fingerprint. And what this is every color represents a particular capability that we've trained our system to detect. We have about 100 right now. And then the width of the bar represents the confidence that we have that capability exists. And if you hover over these, it will tell you what that color actually means. And other samples in the same view that share that capability will light up. Now this is useful for not only getting a first pass idea of what these things are doing, but you can clearly start to tell what samples are similar. So we sort of expected these samples to be similar because they were all part of the same intrusion set, and in fact that seems to be corroborated. But we can also see that there are two that are slightly different. Instead of modifying Windows services, they engage the registry in a more specific way. So what this lets me do as an analyst, so instead of having to individually reverse engineer each one of these and run each one of these in the sandbox to try and determine what's going on, I can already see that they're pretty similar, so maybe I could select a couple of these and label them in some way so that I would know that I can look at, for example, pick one representative sample from this group to reverse engineer or run in the sandbox, and then apply that analysis to the rest. Now, this is very high level, but even in this view, I can get more detailed information. So if I hover over one of these rows, and maybe I'm interested in exactly why the system believes these capabilities exist, I can click on capabilities. I can open up one of these detected capabilities. So I opened up the one for reads writes from Windows console, and I can actually see the tokens that we extracted from the binary that makes our system believe that capability exists. So, and the way our machine learning system works is we took millions of Stack Overflow posts and we looked for string tokens within those posts that occurred frequently in posts about a particular capability X and infrequently in all the other posts. So that if we saw that string token again, it would be likely in a binary, it would be likely that that capability exists in the binary, especially if we saw multiple tokens related to that capability. So here we're seeing the string tokens that we extracted, and we're seeing the probability that the capability exists according to our system given that token. And then we're seeing representative Stack Overflow post where we saw this. So in some cases, this capability is reads writes from Windows console. Some of these strings are very human readable, like write console W. But maybe there are others that are more rare or strange or that you haven't seen before, like get ACP or peak named pipe or who knows what. And so maybe what you want to do is actually go and look at the Stack Overflow post and try to understand in context, like why is that string related to this capability, and do I believe the system or not? So I can actually go to the Stack Overflow post and read read the whole thread and try to understand what's going on here. So this is very useful for an analyst in general, but especially a junior analyst that might not have decades of stored knowledge about this, um, about DLLs and function calls and parameters that are used for different capabilities. And what this also means, we trained our system on Windows binaries, but we could very easily train it to look for capabilities in Android or iOS or OS X, and it would continue to work, and the system would continue to evolve even as programming languages and platforms evolve. So that's our basic search view, but there are other ways of looking at samples too. So I can switch over to what we call our Cynet, or network visualization. And here what we see is when you arrive here, you can select between groups that you've uploaded, any tagged groups that you or other people have tagged, and you can also enter in particular hashes of files that you're interested in. So let me pick a couple of groups of samples that have been tagged and drop them in. And what we see happen is every little gray node represents a malware sample or software sample in general. And then the larger nodes represent labels. So I dropped in 3 groups, so that's why there are 3 labeled groups up here. And then, I'm not sure how well you can see this on the projector, but similar samples will become connected via edges and cluster together. So if I was just, as a malware analyst, given a bucket of stuff to look at, or maybe over several days given buckets of malware samples to look at, I can drop them in here and see which malware samples are similar and can be looked at together. Or I can pick one representative sample to reverse engineer or run in a sandbox. So if I click on one of them, at the bottom here I see rows like in the faceted search representing that one malware sample and its neighboring samples. In addition, so I dropped in a couple of groups. I saw that there are some clusters of similar malware samples, and our system has a large database of right now about 35,000 other samples that we've uploaded. If I click on one of these samples, I can see that there are other similar neighbors in the system as a whole. So I can tell it to go and fetch those similar samples and drop them in here. So even though it wasn't part of the labeled intrusion group that I was looking at, I can still go and find are there malware samples that maybe someone else looked at and did some analysis on, and I can reuse that analysis. So now these are dropped in here, and I can do the same sort of tagging and labeling that I could do in the search view. And in addition, there are a couple of other things that I can do. On the right hand side here, I have a panel that is showing me attributes of related to all the samples that are in view here, and I can and the counts of the number of malware samples that have each attribute. And so maybe when I hover over these, and when I hover over these, they light up. So maybe for some reason the fact that they share a host name or share an IP address or share some other attribute is of interest and makes me think I should look at those files together. So I can actually drop in additional label nodes. Let's see where that dropped in. And this will stick around as I do my exploratory analysis. And so maybe I would want to go and look at these 2 files together. Okay, so far we've gone from like a really high level like landscape view of the data to searching through the data with attributes to looking at it in this network visualization. And I'm able to glean some idea of what these files do and which ones are similar or not. But maybe I need to look at a very low level at some files that I think are similar and understand exactly how they are similar or differ. So what I can do here is I can jump into a comparison view. And what this is this, so what we see here is on the left-hand side of these little blocks. This represents the malware sample that I just clicked on. And then going from the left to the right are the neighboring samples that were clustered together in that network visualization, going from most similar to least similar to that first one that I clicked on. And what I've done here is I've broken apart the data that we extracted and the analysis that we've done into different data dimensions: capability, strings, DLLs, function calls, images, tags, IP addresses, host names, registry keys, etc. And what I have on the most left-hand side are these similarity histograms that show me how many of those neighboring samples are 100% similar in that particular data dimension to 0% similar. So I have, for example, of these 17 samples, there are 11 of them that are 100% similar in capabilities. There are only 2 that are 100% similar in the extracted string tokens. So I can actually then narrow down, based on this similarity histogram, which ones I'm interested in comparing. So maybe I'm only interested in looking at files that are 75% similar in capabilities or more. So I've narrowed it down. And then what I can do is I can actually open up these sections. Let's hope it works. And actually look at the low-level features. So here I can clearly see that our automatically detected capabilities, how many, like 10 of these are absolutely identical, and then 1 has an additional uses Silverlight capability. When it comes to the strings, you can see I have 137 pages of strings that I could go through here, and I can sort this in different ways. So by clicking on each of these little Venn diagrams, these blocky Venn diagrams that represent each malware sample, I can sort that particular data such that in this case, the string features that are present in this particular malware sample get sorted up to the top or at the bottom, and then the other malware samples that share that feature will also have a block in that row. So by going through this, I can clearly start to see which of these samples are actually similar or not, and how, if they are differing, how they're differing. So, I can see that there's one additional one that is absolutely identical in everything, including an IP address that we extracted, and then they start to become more and more different. So I can see how the software is evolving, or see if they're actually have a similar provenance or not, and make some determination about what I can look at together and what I have to look at separately. And just like in the other views, I can select some of these malware samples and tag them in some way so that I can find them again in the system. Let's see. And finally, there's what we call the homepage view, which is accessible from many different points in the system. So this is a general report on one individual malware sample, and it shows me the neighborhood of similar samples. From here, I can jump into that comparison view again. It shows me all the different groups that this file was ever uploaded as a part of. It shows me all the different observations of this file. An interesting thing that our system can do is it can automatically generate Yara signatures, because as part of the analysis process, in addition to doing that machine learning to figure out the capabilities, one thing that we're doing is so we break apart the binary into these string tokens, and then we're keeping a global count, approximate global count, of how often every string token is seen in our entire system. So by definition, we know which string tokens are actually very unique very rare, and we can use that to generate a principal Diarra signature as opposed to a human thinking, oh, this string looks interesting, let me use that. Um, and then you can also see all the images that we extracted. You can see the similar samples here in the row view, and you can see the capabilities with all the evidence for each one. And just like I showed you in the popover in the search view, you can jump to Stack Overflow document for any one of those pieces of evidence and try to understand it better. And then we have just a list of the most rare strings in case it's of interest. And one thing that you can do is a lot of our site is hooked up, so you can search for samples that share any of these attributes that you're seeing. So I have some crazy string token here, and I can actually go and search for all samples that share that token. Now, do I know why these three have that token? I don't know, but it may be of interest to me to dig further and understand these. Yeah, so that's the basic walkthrough of the system. Does anyone have questions, comments? Yes. Yeah. Right. Right. So right now, so what we have right now is a beta site up where people can go and play with it. So we don't have it hooked up to do the dynamic analysis, but the idea would be that, you know, if we were running a private instance of this, in addition to being able to select some things and add a tag, you would select some of these samples and hit a run in sandbox button, and that information would percolate back into that sample homepage and into the features that you see here in the, you know, the filters. So right now we're doing our similarity based on static information, but during our research process, we had an ensemble method for doing the similarity that included doing dynamic runs and generating fingerprints like this, but for dynamic sequences of events that happened. So we have looked at, so that was one reason that we wanted to do the ensemble similarity, because running it in a sandbox would help get around some of that. We have also looked at integrating unpackers, but honestly we haven't found any good ones that can actually unpack you know, custom packers. So right now what you'd see is things are similar because they use the same packer, is what you would end up seeing in our system, until we can integrate unpackers. No, what would end up happening is it would end up attached to both groups. So it would, you know, so you'd have one of those label nodes, then it would have an edge connecting it to some samples in that group, and then it would have an edge connecting it to some samples in the other group, which is a good way of seeing, like, there actually is some shared code between these different intrusion sets. And so if any of you are actually malware analysts and are interested, you can actually go to www.cynomix.org and register, and I can create an account for you guys to play with the system, upload files. Any other questions? All right. Thank you very much. And I'm going to be over at the Zachary Piper / Invincia booth the rest of today and tomorrow. If any of you guys have extra questions.